Today we're going to look at the area of a triangle. We're going to start by first looking at the area of a rectangle. And we know for the area of any rectangle or any quadrilateral, we can find it by counting the number of 1 by 1 squares. But the easier method for us is to know that we can do it by multiplying the length times the width. So 3 and 6 gives us an area of 24, and if we were to count each of our squares, we'd find we get 24 squares. So now we're going to move on to the area of our triangle. And for our triangle, we have this height of h and this base of b. And now what I'm going to do is I'm going to clone this triangle. So I have an exact copy of this triangle over here. Same height h, same base b. Now I'm going to flip this triangle. And I do it, and you can see even my h and my b flipped. But now I have a rectangle. And now, so I can use the same formula I used for a rectangle to find this whole shape. So that would be my height times my base. But we're only looking for the area of one triangle. So we're just looking for the area that's purple. And so I know that that's 1/2 of it because I have two triangles, so I divide by 2, which gives us our formula, 1/2 base times height. But now this does work for other types of triangles. And we can see here, this triangle has the height in the middle of it and the base across the whole bottom. So what we're going to do is I'm going to split this into two triangles. So I have triangle x, triangle 1 here, and triangle 2 here. Triangle 1 I'm going to say has a base of x, and triangle 2 has a base of y, as you can see here. So I can find the area of triangle 1 using our formula by saying that triangle 1 is 1/2 of x, which is its base, times its height, and triangle 2 is 1/2 y, which is its base, times its height. So now, because I want to find the area of this whole triangle, I'm just going to add them together. So I add them, 1/2 h. Now I'm distributing a little bit here, so I have 1/2 of h, because I took both the 1/2 and the h out because they're the same in both of my triangles. So I have 1/2 h times x plus y. Now if I remember from over here, x plus y was the same as b, so I can just change my x plus y in the parentheses to a b. And then by doing a little distributing, I have 1/2 base times height. So we see that this even works if the height is in the center of our triangle. But what if we have a strange shape like this where the height isn't in the center and isn't on the side? Well, we can draw in a little height over here, and we just add on this extra little piece. So I'm going to call this little triangle here A, and it still has our base of B. But the little triangle, I'm going to say, has a base of x. So I can easily find the area of this little triangle by saying that area of triangle A is 1/2 my height times x, which is my base. But what I'm really looking for is the whole triangle. So I know the area of the whole triangle is 1/2 my height times the base, which is x plus b. Now, by doing a little math here, I can say, so I want to take the area of my large triangle and subtract the area of this smaller triangle out of it. So I have 1/2 h times x plus b minus 1/2 hx. And so now I'm just going to do a little bit of distributing, and I end up with 1/2 hx plus 1/2 hb minus 1/2 hx. So now I know I can easily cross off my 1/2 hx's, so I'm left with 1/2 hb, which is the same as 1/2 base times height. So you see this formula works for any triangle.